Does anybody remember what momentum is equal to from the Paul Hewitt video?
Isn't it force times change?
No, you're thinking about impulse.
It is like change, mass, and velocity.
Yes, mass times velocity. Can anybody remember what the variable for momentum is?
It's like 3 helps.
No, it's
No, that was the mass.
lowercase p. P equals mass times velocity. Can you guys remember what these little symbols mean over the P and the V? Vectors, okay? All a vector means, remember you guys, means it has 2 things. It has direction and it has magnitude, right? So if something's moving to the left, what's its direction, positive or negative? To the right? Up? Positive, down? Negative. That's all it means. So when we talk about momentum, the momentum of the object is going to have the same direction as the velocity, okay? Momentum will have the same direction as the velocity. So if the velocity is negative, the momentum is? If the momentum is positive, the velocity is? Positive, okay? So if we change the mass of something, does this momentum change? If we change the mass, the momentum doesn't.
Yes.
If we change the velocity, does the momentum change? Yes, right? So it's dependent on these 2 variables. So let's give this a go. Oh, also the unit. That'd probably be important. The unit is kilogram meters per second. Kilogram meters per second.
So it's just combining both units?
Mm-hmm. That's all everything is combining units. This one just doesn't have like a 1 letter that we give it. Like joules is literally just a combination of all the units and then we give it a pretty name. But they didn't do that for momentum or impulse. Okay.
The line above the P.
Vector.
So that's supposed to have an arrow.
It has a little tiny one attached to it. I'm just bad at drawing them. All right. So, for an example, we have a 1,200 kilogram car. What variable would a 1,200 kilograms be? Mass, okay. We have a car with a mass of 1,200 kilograms. Awesome. And it's getting driven through town. Let's say they're driving east in town, and they're driving east at 15 meters per second. What would that be? Velocity. Is that going to be positive or negative? Positive, because it's east. We want to know what is the momentum of the car. How would we find it? Yeah, we're going to take the mass, and we're going to multiply by the velocity. What did you say it was, hon? 18,000. 18,000. Look at that. What are the units? Kilogram meters per second. That would be the momentum of the car. Is that good with everybody?
Yes.
Yeah? Okay. I see some of you guys are still writing, so I'll leave it up there for a second. I took off my mask to eat lunch and I couldn't find it, so I had to put on this one. And this one's like really thick.
Mine's thick too.
I feel like it's hard to even hear me talk in this thing. Okay. Can I erase this now?
Mm-hmm.
Yeah? Awesome. Okay. So let's think about another one. Who in here has a dog or a cat or something that gets excited to see you when you get home? Right? Okay. Do they like come running to you at the door? Yeah, okay. So let's talk about how fast whatever runs to you when you get home runs to you, even if it's like rats or mice or something, okay?
No.
Or cockroaches or no? Okay. So let's say that our dog has a mass of 12 kilograms, okay? That's about a 26-pound dog, give or take, okay? And it's coming over to you with a momentum of 37. 37 what? Yeah. Okay, and I want to make that positive. So that means your dog's like running to you to the right or something. Or consider the front of your house a positive direction, okay? We want to know how fast is your dog running at you. So how are we going to take this equation and rearrange it to solve for velocity? Yeah, you're going to take the momentum.
3.0.
That was fast as what?
3.08
3.08 what?
meters per second.
Velocity. I heard that. I heard that. Okay, so is that good for everybody? Okay, cool. So far, so good. Now, everybody already said that we totally understand, right, that whatever the sign on the velocity is will be the sign on the momentum, right?
Right.
Okay, just remember that, okay? Because now we're going to talk about the change in momentum and how we find the change in something's momentum, okay? So, is this little bit okay to erase? It's those learn from home kids. They never tune in to any of their meets, so I have to record during your class. It really is. Like, I haven't opened the whole, like, hour-long class. Not a single person will tune
I
in.
could understand if it was 7 in the morning because I would have attended if it was 7.
They don't tune in, so I'm like, well, I guess I have to record it now. Okay, so it's third period. That's my blended.
That's 9? Oh, yeah, I probably wouldn't.
Okay, so change in momentum. How from the beginning of the year have we always classified a change in something? We said something minus something.
Final versus minus initial.
Final minus initial. So we're going to take whatever our final momentum is and subtract the initial from it, which is like saying your final minus your initial, right?
Yeah.
Okay, so that's what we're going to deal with here. Yeah, you have a question?
I was wondering, could you take out the math? Because in most cases, the math won't change.
Technically, you couldn't like get rid of it, but you could like bring it out to like the outside. Alrighty.
Are we doing a graph?
It's not a graph. I'm setting up a frame of reference, a reference frame. We talked about it on the first day of class. In physics, we love reference frames. Yes.
So the math video is greatest common factor in that case. So it would be m times b minus b naught.
You can do that, yes.
Okay.
Alrighty. If you guys are wondering what they're saying, they're just asking if they can do this and be lazy.
Oh my God, I'd rather write it.
But the lazy
I feel like I
people.
get confused when I do that.
Well, yeah, most of you guys end up getting confused, which is why I don't
Wait,
do
are
it.
you wrong? It's wrong.
It's a reference of something.
It is a reference frame, so we can know what's going on in the example I'm about to do with you guys, okay? Woo. Fifth period always tests my patience. Oh my God, it's a reference frame.
Right.
So we can know what's up and what's down and all that fun stuff. Right.
It's a reference frame. I get it.
Yes. Yes. You're putting it on your paper. If I put it on this board,
What is it again?
it's going on your paper, Anderson.
Yeah, I remember somebody said from learning phone, they don't know how to do it.
Oh, yes.
It's a reference frame. I remember.
We literally went over reference frames the first day of class. Okay. So, did anybody's family collect Beanie Babies?
Oh, yeah.
Other people said in third period that they were known as TYs. That's the brand, not what it's called. That's the brand. Okay.
What's a
Those little stuffed animals, yeah. They're like these really tiny stuffed animals that a lot of people, for some reason, thought were going to be worth a ton of money one day,
Yeah.
but ended up being worthless.
Are you serious? There was a video game too.
Yeah, there's like no point. Okay, so we are going to be calculating the change in momentum of two objects.
Mhm.
One will be a Beanie Baby, one will be a rubber ball, okay? So I'm gonna try to draw a little Beanie Baby.
Just something.
Is that off? Oh, it's a frog.
It's true. It's probably an octopus one, right? No. That's cute.
That's a little bear, okay? That's a little Beanie Baby. The Beanie Baby is falling down, okay? The reference frame lets us know that it's starting at some height falling towards 0. The reference frame, okay? Then there's also a rubber ball which is falling down as well. Both of these objects, the Beanie Baby is 1 kilogram, the rubber ball is 1 kilogram, and they are both falling at a speed of 4 meters per second. If it's a velocity, should it be positive or negative? Negative, because it's falling down, okay?
She's laughing at my Beanie Baby.
Would something happen to the rubber ball is it'll bounce?
So what do we think is going to happen to the Beanie Baby when it hits the ground?
Still there.
He's going to hit the ground and he's going to stay there, okay?
Beanie Babies are like stuffed animals.
Yes. There's no
Bees. They're bees, not bees.
Beads, the little clear beads.
yes.
I just like that.
Okay, he's going to stay at the ground. And then, like Trunk says, what happens to the rubber ball?
It's gonna go back up and bounce up.
It's going to bounce back up. Okay? What do you think this Beanie Baby's velocity is at the bottom?
0 meters per second.
Okay? And when this one reaches around the same place, it's going to be going 4 meters per second, okay? It's going to be positive or negative now? Positive, okay. So the first thing we want to do is we want to find the change in momentum for the Beanie Baby.
Of course.
So what is the mass of the Beanie Baby? What is the initial velocity of the Beanie Baby?
-4.
What is the final velocity of our Beanie Baby?
0.
Okay, and what are we trying to find?
Change in momentum.
Which means we'll be doing the final minus the initial, right? Okay, one of these is 0. Which one?
Final.
Yeah.
Yeah, because remember, you guys, this is M VF minus MV naught, right? And VF is 0. So we can get rid of it. So now we have that the change in momentum is equal to negative MV naught. Can we plug it in now? Please do not type this into your calculator, like I beg of you.
I'm gonna
You know
guess
there's
that
still
it is 7.
So it's not 1.
It is 4 or 5.
It's positive 4.
Yeah. Okay, I can slow down. That's fine.
Yeah.
I'm sorry. People were just yelling at me the answer before I even started writing anything.
Hold on, let me write that down.
Yeah, I just got the answer. I didn't write it.
Yeah, I mean, if you could have looked at it.
I don't know what you just said, but sure. Right.
The reason the MVF is crossed out is because we know that VF is equal to 0. So if we multiply anything by 0, we get 0, okay? So we're going to cross it out because when we do 0 times M, it goes away. So that means we don't have to worry about it in our math anymore. So all we get left with is just the negative initial momentum, okay? And then we plug that in and we get our answer of 4 kilogram meters per second. Okay? So now we're going to talk about the rubber ball. Okay, you guys, what is the mass of our rubber ball?
1 kilogram.
What were we given as the initial velocity of our rubber ball?
-4.
What were we given as the final
4
velocity?
meters per second.
And what are we trying to find?
Change in momentum.
Which is equal to What minus what?
Final versus initial.
Final minus initial. Okay, you guys? So I'll give you guys a second to get that down. That's everything that we're given. Okay? From there, we can expand what the final and initial momentums are so that we can see how it relates to our variables. So we're going to have the mass times the final velocity minus the mass times the initial velocity. Is anything going to be equal to 0 this time?
No.
No, okay? So we're going to have to plug it all in. We'll have 1 kilogram times -4 meters per second minus 1 kilogram. Oops, sorry, it's +4 at the beginning. The -4 is the initial. So we have 1 times 4 minus 1 times -4. Okay? When you think you have the answer, you can tell the class.
8 kilometers per hour. I don't know how to say it. Kilometers, is it?
8 kilogram meters per second. Okay, you guys? Does that make sense?
Yes.
Yes. Okay, cool. You promise?
Yes.
No? Well, what do I need to go back over then?
No, you're good, I just can't find it.
Oh, okay. What's what? Nothing?
No, he's talking to me, I was like, I just can't tell him saying
Couldn't you mark out the ends and still get the same answer?
Okay, so we've got another part of momentum to go over. Think back to everything we've done so far. You learned what it is, the most basic equation, right? Then we talk about the change in it. Then what do we usually go to? Think about what we just did with energy. We learned what energy is equal to, what the change in energy is equal to, and then total, right? Like, so if we're summing stuff up.
Right.
So we're going to learn how to solve for total momentum of a system, okay? So just like with the other ones we did, we would say that the total of it is equal to summing them all up. So the total momentum is equal to the momentum of one object plus the momentum of a second plus the momentum of a third, and so on and so forth to sum momentum in. So whatever the biggest number is will go there, okay? So that's what we are going to do now. Before we will start, though, I want to let you know that our total momentum can be positive, it can be negative, and it can also end up coming out to 0, okay? Just like everything else you've done, because since it's a vector, doesn't that mean this one could be positive and then this one could be negative?
Mm-hmm.
So what if one thing has a momentum of +4 and the other one has -4, and I want the total momentum of them together? It's going to come out to 0, okay? So all of those are possible. So if you get 0 or if you get a negative number, it does not mean you necessarily did something wrong, okay? So we are going to talk about a problem where we're going to add together 3 momentums, okay? Anybody play Duck, Duck, Goose?
Yes, I love that game.
Okay, so that's the name of this one. But we're not playing the game Duck, Duck, Goose. We're talking about 2 ducks and a goose, okay? Who has ever gone to, like, the park and thrown bread out at them to feed them?
Well, the lake,
Yeah, or the lake?
Mm-hmm.
You're technically not supposed to do that. It can kill them. But it's fun, right?
Really?
They'll eat too much and then it expands in their stomach and then they die.
Oh.
It's just like one of the best ways to get rid of ants is you take a bag of grits and you sprinkle the grits on the anthill and then they eat them and then it expands in their stomach and kills them.
I didn't know that. That's smart.
It expands. That's one of the reasons why carbs makes you feel so full instantly. Yeah, you get bloated.
That makes no sense, because it already grew when you make it. They grow more.
Yeah.
It absorbs right as food.
And bread is delicious. I love bread.
Me too.
Anyways, we're at a park, all right? And don't worry, feeding a duck a little bit of bread isn't gonna kill it, you guys. Gonna be okay. Huh?
Why it's not yours, do they give you bread?
I said a little bread won't kill them. Just like I have chickens and I can't feed them a lot of my bread because if I feed them too much bread, it's bad for them. Too much of something is bad for anybody, okay? All right, so we've got 2 ducks and a goose, okay? The 2 ducks each have a mass of 4 kilograms. So the mass of duck 1 is 4 kilograms. And the mass of duck 2 is 4 kilograms. Do you think that the goose weighs more or less than the ducks? More, okay? The goose is, I think it's 7.6. The goose has a mass of 7.6 kilograms. Okay, so that's everybody's mass. Does anybody here hate geese? Because I hate geese.
Yes, I'm terrified.
Yeah, they're really mean. They're really mean. Geese is multiple of a goose. So I'm not gonna say, does anybody hate goose? Oh, hush. The ... is because you could have a 4th one, a 5th one, a 6th one, a 7th one. You never know how many there's gonna be.
Right.
And then the N just stands for some number. So that could be like if you have 20, it would say that you're going 1, 2, 3 plus everything in between all the way to the 20th one. Okay? So the ducks are moving to the left. So is their velocity going to be positive or negative?
Negative.
Okay, so I'll go ahead and put velocity of duck 1, velocity of duck 2. We know they're both going to be negative. They are both going negative 1.1 meters per second. Okay? And the goose is moving to the right. So will theirs be positive or negative?
Positive.
Okay. The goose is going a positive 1.3 meters per second. All right? And we want to know the total momentum of all of them. So that'll be momentum of duck 1 plus the momentum of duck 2 plus the momentum of the goose. Okay? So if we want to write this all the way out, remember that it's going to be mass times velocity for each one of these. So you guys should be able to do that at your seat while I do it up here, okay? I'm just going to write mass of duck 1, velocity of duck 1, plus mass of duck 2 times velocity of duck 2, plus the mass of the goose times the velocity of the goose. You guys, this G represents goose. It does not represent the acceleration due to gravity, okay? So don't get it confused. Yes, ma'am. Well, just because, I mean, these are my people. These are my ducks. These are my geese.
I didn't know if you just do like MPD1.
I mean, if you did that, you would be assuming that the M's are the same, which here they are, but you never know. You could get told that duck 1 was a mass of like 5 and duck 2 was like 3. So it's just to have repetitiveness while you guys are learning this, okay?
Yep.
So after you do this, you can go through and you can start plugging in your numbers so you can see what they would look like. So you would have 4 times negative 1.1 plus 4 times negative 1.1 plus 7.6 times that positive 1.3. And if you want to type everything into your calculator like this, that's fine. But if you want to like say that, get the like sum of each one, that's okay too. Like the product of them, you can do that too. So I'll write that out below if you're somebody who would rather do that.
I'm the one who put it all at once. Call it a name. You get point. You want 1 kilogram.
Before we start yelling out the answers, I want to make sure everybody's on the same page, okay? Yes.
So, wouldn't it be better to get the individual, momentums in case you needed them for something else, like a word problem or something?
You can if you want to, yeah. See, so here are the individual momentums.
I had just done that, but I was just making sure.
Yeah, if you do that, that's fine. It's up to you. Because if you end up needing them later, you can always just find them again later.
You said it's kilogram meters, right?
Kilogram meters per second.
Not kilometers now. I don't know what that is.
Okay. So are we all in the same place? Do we understand what's happened so far? Okay, so what's our final answer?
1.08 kilogram meters. I can never use the same. Over second. You got put up the over second? I did say over second. Did you really?
Okay. Now, if the duck's velocity stayed the same, would this goose's velocity need to increase or decrease in order to make the total momentum equal to 0? Okay, shush. If you want me to repeat it, you have to be quiet so you can hear me. Okay, if everything stayed the same with the ducks, right? They're the same mass, they're going the same velocity. What would we need to change about the goose's velocity in order to make the total momentum of all three of them be equal to 0 instead of 1.08? Would the goose need to go faster or would the goose need to go slower? Well, we are split, aren't we?
It has to be faster because it weighs.
I don't know.
Well, let's see, okay? Let's walk through this together because I'm hearing both answers. We're going to find out what the goose's velocity would have to be. Okay, so I'm going to get this stuff set up again. I'm just going to write it over here. But now, instead of putting P total next to it, I'm going to put equals 0 because we want to find out what happens when it equals 0. And which of these variables are we trying to find? Yeah, the velocity of the goose. That's all that's changing, okay? Everything else is staying the same as what you were originally given. We're just looking for what the velocity of the goose would need to be to make this whole thing 0, okay? So what do we need to do to get the velocity of the goose alone?
You have to subtract that whole thing over there and then divide by the MG.
Yeah, okay, so we're going to take, you see how all these terms are getting added? We're going to subtract this term from both sides, and we're going to subtract this term from both sides. Why we're doing that is because then we'll get the mass of the goose times the velocity of the goose is equal to the negative mass of duck 1 times the velocity of duck 1 minus the mass of duck 2 times the velocity of duck 2. So this is like the rearranging we've been doing the whole time, you guys. If it's getting added and we want to get it over to the other side, we subtract it. If it's getting subtracted and we want it on the other side, we add it. If it's getting multiplied, what do we do to get rid of it? Divide. If it's getting divided, we multiply, okay? What's the last thing we would need to do to get VG completely alone?
Divide by MG.
Divide by the mass of the goose, okay? So that means that we would have negative 4 times negative 1.1 minus 4 times negative 1.1 divided by 7.6. We'll give everybody a second to catch up, okay?
And then
You couldn't mark up the M's here.
Nope, because they're different M's.
What did you say to me?
oh my god.
You said 3.8.
Okay, what do you guys think the answer is?
1.1.
What are the units?
Meter.
You're right. You have to do 3.8.
that.
So, did the goose have to go faster or slower? Slower. The goose had to go slower.
Wait.
If the total momentum would have been negative, the goose would have had to have gone faster to get to 0.
Leave it alone.
But since it was positive, it had to go slower to get to 0.